All right, group, a system of equations. Now, when we're talking about a system, okay, you already know what the equations part is, right? We've dealt with equations. But a system, what do you think a system means? What does that imply? A system of equations. What does that imply?
The way to break down equations.
Okay.
More equations at the same time.
More equations. So it's more than one. Okay, so now we're not dealing with just one equation, we're dealing with usually two equations. Okay? So a system of equations is one or more equations with the same variable. Okay, with the same variable. An example of this would be y equals x plus 3, y equals x squared minus 5. Okay, that would be a system of equations. They both have a y and an x. Okay, now one of them is just a regular line, and one of them is a quadratic, but that's okay. They still have the same variables. Okay, to solve a system of equations, so if I ask you, if I give you a system of equations that looks like that, for example, and I say solve this system, you are looking for where those two graphs intersect. We call that a solution. I don't know why it says and, but it should say and. This is a solution. Okay, and it will be written as an ordered pair. Okay, so it'll be x comma y. It'll be a coordinate point for where they cross. So basically, where two graphs cross or intersect is basically saying that the ordered pair contains the x and y values that make both equations true. It makes both equations true, or all of them, because sometimes we have more than two. Okay, so there's a few different ways that we can have solutions for these systems. Okay, the first is where we have an ordered pair for solution. We just call those intersecting lines. Okay, just normal intersecting lines, and you have a coordinate point. Okay, now, if the lines had no solution, that would mean that they would never intersect. What type of lines never intersect? Parallel lines. So if we had a system that looked like that, if it was parallel lines, we would have no solution. Now, where would we have infinitely many solutions? What would that look like? Intersecting lines was the top one. What do you think? If they had all the same solutions, it would be the same line. So if we had like an equation that we graphed, and then we graphed it again, okay, and they were, we'll see it on Desmos where they're like right on top of each other, that means it's the same line, just written in a different way. Okay, so the same line where the solutions are infinitely many. Okay, questions on that for me? All right, Tyler, did I give you a packet? A note packet? I did give you one. No, I didn't. Okay, so we're going to go ahead and use Desmos to help us. Okay, so I'm going to pull up Desmos. Okay, and we're going to put in that first graph. Okay, which is, the first equation is x equals -2. So I'm going to type that into my first line. And then the second equation is -3x plus y equals 9. Okay, so when you put these in Desmos, you'll type the equations in on two different lines. Okay, and then you want to look for where they intersect. Now, what I would do me check. Yeah, we need to kind of roughly graph it. So I would just graph a few points on each line. So the blue line, for example, well, that'll be fine. We'll just do those two. So go ahead and plot the points -2, 3 and -3, 0. Okay, and you can kind of draw a line through that. That should be just fine. Oop. Okay, so again, those points were -2, 3 and -3, 0. So we're drawing that blue line that's up there. Okay, and then the red line is actually pretty easy. It's just x equals -2. So it will be a vertical line through x equals -2. Okay, now both lines intersect at what point? -2, 3. Okay, and our solution from Desmos was the same. -2, 3. Now, technically, we didn't need Desmos to help us graph that. We could have graphed it just by knowing. Okay, what would we have had to do to this equation in order to be able to graph this without Desmos?
Or no, do you fully y?
We're close. We don't want to subtract 9. We want to get y by itself. We would need to add 3x, right? So we would have 3x plus 9. Then you could have graphed those by hand. But you guys will be able to use Desmos. It's probably the easiest way to solve for these. Any questions for me? Okay. Next one. All right, so let's go ahead. We're going to do this by hand first, just so we get some practice. The second equation's fine. We don't need to do anything with that second equation. How am I going to solve for y on this first one? What do I need to do first? Yeah, you can add, well, not 2, add just 2y, right? Because those are together. Okay, so we have x equals 2y. And how are we going to get y by itself? Divide by 2. Okay, now this looks a little weird. I'm going to write it like this instead. 1/2 x. Okay, now, there's something missing to that equation. What's missing? The y-intercept. Okay, now, if we don't see a y-intercept, we assume 0. Okay, so we're going to graph this guy and that second equation. Both of those are good and ready to go. So, rule of thumb, if I ask you to show me the work, okay, then that means that you need to rewrite the equation and solve for y and then graph. So I'm going to go ahead and graph this first one up here. That's a little bit easier. So go up to 6. And then down 1 over 1. Okay, now, I will tell you, if you're doing these by hand, you need to extend that line all the way through because you don't know where they're going to end up intersecting. If you don't go all the way through the graph, you might miss that intersection point. Right, our second one starts at 0. Okay, is your intersection point 4, 2? Yes? Okay. So our intersection point from our graph is 4, 2. We're going to go ahead and check Desmos. So if you look at how I wrote in, or I typed in the equations, I didn't have to rewrite anything. I can just put them in exactly how they looked originally, which is kind of nice. All right, let's check to make sure our answer was right. Oh, did I say 2, 4? Did I write it wrong? Oh, no, I wrote it right. All right. 4, 2. Okay, so that's what we're doing today. Okay, we're working on graphing, tracking content. I do want you to practice by hand because it is really good for you to take a rewrite. All right, let's go. Now we're going to go backwards. Okay, and we're given the intersection point and the equations. Okay, and we're given the intersection points with the graph, and we're going to write the equations. Okay, now, first equation, let's go ahead and do this one right here. I'm going to go ahead and put arrows on it. What is our y-intercept for that equation? 3, right? It crosses here at 3, and then we're going to find our slope. What's our slope? -1/2, right? It goes down 1 over 2. Our slope is -1/2. So if we put that into y equals an x plus b equation, y equals -1/2 x plus 3. Guys, our phones should not be out during a lesson. Never, ever, ever. Put them away. Okay. All right, equation 2. So let's do, I'll make this one blue. It's easier to see that way. Okay, what's our y-intercept for that one? -4. What's our slope? Yep, 3 over 1, and it's positive because it's going up. You don't have to write 3 over 1, you can just write 3. Really, that's up to you how you write that. Okay, so if we put this into an actual equation, y equals 3x minus 4. So we should be able to go both ways. Take equations, draw the graph, take the graph, write the equations. Okay, so if you are a step person, the first thing to do is to find the y-intercept. Okay, that's that b value for y equals mx plus b. So if you're a step person, you can write these down. Okay, so find the y-intercept. The second one, or the second step, is to find the slope. And then third step, put into y equals mx plus b. Okay. If you're a step person and you'd like to have those written down, you can find a place there on your notes to write that. All right, next one. Let's go ahead and we'll start with this one over here. Okay, I want you to go ahead and tell me what's the y-intercept. -1. And what's our slope? Yep, and is it positive or negative? -1. So y equals -1x minus 1. Yes, you could just write it as -x instead of -1x. Guys, let's put our phones away, please. All right, equation 2. This other one here. Our y-intercept is 3. And our slope?
2.
Down 2 over 1, so that would be -2. Again, you can write it as -2 over 1, but you don't have to. Just write -2. No, you don't have to. I just have found that it really helps my students a lot if they do, so that's why I teach it that way. But if you're good and you feel like you don't need to write that in me. Okay, now, it does say up here in the directions, check your equations in Desmos. I can't stress that enough. It takes you 30 seconds to type those in and make sure that everything looks exactly how it should. So I would always do that on your quizzes or tests because it's an easy way to make sure that you got those right. Okay. All right. We can also have systems of equations with quadratic functions. So like the first one that I showed at the beginning, if you have an x squared in there, that can happen. That's okay. The solution set works in the same way. So we can either have no solution, okay, or we can have those intersecting points. So let's brainstorm what the system of a line of a quadratic could look like. So let me give you a system. Okay, so what if I had these two equations? Okay, I'm just going to show you kind of what these will look like. Does anybody know where y equals x squared, like what that looks like, where it starts? No? Does anybody know where the vertex would sit?
3.
It would sit right here. Okay, so that is the y equals x squared equation. That's this one here. The x squared plus 3 means that it moves up 3. Okay, so what would happen with the quadratic is it would actually intersect another quadratic 2 times. One's right here and one's right here. Okay, now I want you to think about a quadratic. So let's say here's our quadratic and a straight line. What could happen if a straight line goes through a quadratic? It could hit twice, right? It could go like this, and then it would have these 2 intersecting points. That can happen. Let's do another one. Could this happen? Yeah, where it only has 1. That can happen. Could this happen? Yeah, right? And that would be no solution. So there's a lot of things that can happen, and as you kind of work through the different problems today, you'll see all those different cases. So don't be surprised if something like that happens. Okay. All right, so number 5, I just want to show you what these look like. Okay, so I typed in y equals x squared and y equals negative 2x plus 3 into Desmos. Okay, here's what happened. Okay, now, I think I need to do that a little bit smaller so we can see the top. There it is. Okay, do you see how the purple and the green, what's up? Did you ever get that?
No.
Oh, okay. Do you see how the purple and green intersect? And they intersect here and here? You're going to have 2 solutions. Okay, so when we write our solutions over here, we write both coordinate points, negative 3, 9, and 1, 1. Okay, if for some reason they didn't intersect, and the line missed the quadratic, you would just tell me no solutions. Okay. All right, let's do the next one. Number 6. Okay, this looks funky, right? It's a quadratic. Both of them are quadratics because they both have the squares there. So let's see what happened with this one. Look at that. One's facing up and one's facing down. How did you know based on the equations that was going to happen? Yeah, one's negative, right, and one's positive, so one's going to point up, one's going to point down. So for this one, how many solutions are there? 2, right? They intersect here and here. So you would write both of them. So anytime there are double solutions, you got to write both. Now, one of the issues that I do see, okay, is that somebody graphs something on Desmos, and Desmos isn't zoomed in enough, and they miss a point. That can happen, so I always tell you guys, when you learn this, make sure that you press that minus button on Desmos, zoom out as much as you can to make sure that you don't miss an intersection. Does that make sense? Okay. Number 7, same thing. So this is, a regular graph and a quadratic. What happened here? None, right? They missed. So this would be no solution. Okay, one more, right? Yes. One more. Okay, so this one, let's see what happens. Okay, this one, is this a quadratic? Anybody know? If I had to do an x times x, what's that give me? X squared. So they both are quadratics. Let's see what happens with these. Oh, look at those. Okay, so one is pointing down and one is pointing up. So there are two intersections. And to be honest, sometimes they're going to look ugly like that. Okay, they're going to be decimals. That is okay. It can happen. You would just write both. All right, next thing. Yep, there's practice attached. Okay, so I want you to work on that. I know that we are out of here in about 6 minutes, so just get as much done as you can today. Okay. 30 minutes is like nothing. It's crazy. Yes.